Hello everyone. Welcome for the course Industrial Automation. In today's module we will be discussing about the components of fluid power system. The objective of today's module will be to understand the working and construction of the various fluid power system components. So the contents that we will go through in this presentation will be air receiver, air dryers, the types of air dryers like refrigerator, low temperature drying, adsorption type drying, and absorption type drying. Then we will also discuss about the air service unit, that is also known as FRL unit, in which we will be in detail discussion about the air filter, air pressure regulators, and air lubricators. Now, first of all, let's start with the air receiver, that is also known as the receiver tank. So you might have seen this type of component in various places, like in tire service stations, in industries. So this component is the air receiver or receiver tank. The function of this tank is to store the compressed air in large volumes. As we know that before this component, the air, we have in the last presentations we have discussed about the air compressors. So the function of the air compressor is to compress the air, and that compressed air is stored in these air receiver tanks. So the air is compressed slowly in the compressor. But the pneumatic system requires the air at a constant flow. So to maintain that flow, we need the constant supply of the air, and that is ensured with the help of the receiver tanks. But since the pneumatic system needs continuous supply of air, this compressed air has to be stored, therefore smoothens the pulsating flow from the compressor. Another issue with the compressed air was that we are getting the pulsating supply of the compressed air. That pulsating supply is also compensated by using the receiver tank. So it also helps us to cool the compressed air. As we know that after the compression stage, the temperature of the air goes up. So we cannot use that air directly into our pneumatic systems because it may damage the plastic components. So when it is stored in these receiver tanks, due to the large surface area of these tanks, there will be heat transfer, and the air inside this receiver tank will get cooled. So the air receiver should be large enough to hold all the air delivered by the compressor. So it should be large enough, it should be of such quantity that it should hold all the air that is compressed by the compressor. The pressure in the receiver is held higher than the system pressure. Now there are two types of the pressure. One is the pressure of the compressed air, and one is the pressure at which the air is required in the system. So in most of the cases, the pressure of the air required in the system is less as compared to the pressure of the air generated by the compressor. So we have here in this, we have the pressure gauge also. So that is used to set the pressure limits of the output air from this receiver tank. So the pressure in the receiver is held higher than the pressure operating system to compensate pressure loss in the pipes also. So another reason why the pressure is high in this receiver tank, because when the air flows from this receiver tank to the system, it has to pass through various pipelines, components of the fluid power system. Due to that, the pressure always decreases. There is always loss in the pressure, and to compensate for that loss in the pressure, we have the supply at high pressure, so that loss in the pressure can be compensated easily. So this thing we have discussed before also. The large surface area of the receiver helps in dissipating the heat from the compressed air. So this, as you see in this figure, the receiver tank has many components are there. So we have the pressure gauge. So with the help of the pressure gauge, it is easy to monitor the pressure of the system. We have a safety valve also. The function of this is also a type of a pressure control valve. It it checks for the increase in the pressure in this receiver tank. If it goes beyond the set limit, prescribed limit, to avoid any type of the accident, so we have a safety relief valve. If the pressure goes high than the prescribed limit, then this air from this pressure relief valve gets exhaust. Then we have, this is the storage tank, and this is the inlet, and we have the water drainage. So we know that the air always contains the moisture. If some of the moisture is getting collected at beneath this air receiver tank, it can be drained out of the water drain. Then we have the thermometer to check for the temperature of the air in the receiver tank, and then we have a shut-off valve. This valve is to control the supply of the air to the next fluid power system components. So this is all about the air receiver tank or the receiver tank. So generally the size of the receiver also depends upon the delivery volume of the compressor. So the size depends upon the amount of the air that is compressed by the compressor and it is sending to the receiver tank. Air consumptions, how much air we are consuming, pipeline network, which type of pipeline network we are having, what is its capacity, type and nature of the on-off regulations, how frequently we on-off the pressure regulation, the air from the how frequently we get the air receiver tank, permissible pressure difference in the pipelines. So these are the various factors upon which the size of the receiver tank will depend upon. Now next is another very important component of the fluid power system, that is the air dryers. Now first of all, let's understand the function of the air dryer. So we know that air always contains the moisture. So when it is compressed and after the air receiver, when it goes into the system, before it goes into the system, we have to remove the moisture, because if we allow the moist air to move into the sliding components and move into our fluid power systems, then it can lead to the rusting of the parts, because due to the presence of the air and water, it will lead to the rusting of the ferrous components, and that will further lead to the corrosion of the components of the system. So to remove the moisture from the air to prevent the rusting of the components of the system is the prime function of the air dryers. So in this, the air dryers are also of three types that we are using. First is the refrigerated or low temperature drying, we can say. Second is the adsorption type drying, and next is the absorption type drying. So now we'll discuss one by one these three air dryers. So first is the refrigerated, or we can say low temperature drying. Now it consists of two stages. So construction you see in this figure. So it consists of two stages. So we have the stage 1, that comprises of the heat exchanger unit, that is the stage 1, and then we have the stage 2, that is the refrigerator unit, that is the stage 2. Now the principle of this is that when compressed air is cooled down to a temperature below the dew point temperature, then the water present in the air, moisture present in the air, it gets condensed and can be precipitated and can be separated out from the air with the help of a separator. Okay, now let's try to understand this construction. So we have a refrigeration plant in the stage 2 that will act as a refrigerator, and it is also known as the chiller. It will chill the air to a dew temperature, that is nearly to the 2 degrees centigrade temperature, at which the condensation of the moisture will take place. And then it has a air to air heat exchanger is also there, that is used to exchange of the heat between the air that is entering the system and the air that is coming out of the system. So this is and we have the separators. The separators are used to separate out the condensed air from the system. So if we see the working of the refrigerant type or low temperature drying, then we discuss about firstly the pre-cooling, that is the heat exchanger stage 1. So this is our stage 1, that is the pre-cooling or the stage 1. So most moist compressed air from the compressor enters the dryer at high temperature and pressure. The incoming air is cooled, first passed to the air-to-air heat exchanger, where it is pre-cooled by the outgoing cold air. Now we see the figure. Now you see here we have this moist air inlet is there. We know that the air is coming from the receiver tank that was stored due to the compressor as the now the temperature of that air is high and the pressure is also high. So when the moist compressed air at high temperature enters here, it exchanges its heat with the cool dry air that is coming out from here, from the dry air outlet. So it is pre-cooled in this stage. It pre-cools here and then it moves to the separator. And here in separator, what happens, if some of the moisture has precipitated, then it will get collected here. Then the pre-cooled air will move to the second stage, that is the refrigerator unit. Now you see next point is refrigeration cooling, that is the chiller section, stage 2. The pre-cooled air then enters the air to refrigerant heat exchanger, that is the evaporator. So same as in our refrigerators. So our refrigeration cycle cools the compressed air further to 2 to 5 degree, that is the dew point temperature. At this low temperature, the water vapor in the air condenses into the liquid water. So what happened? We again come back to the figure. After the stage 1, it enters this refrigeration unit where this evaporator is there. We have the compressor is there. It is a full refrigeration unit is there. The air gets further cooled here up to the temperature of dew point, that is 2 to 5 degree centigrade temperature, below, that is little above the freezing point of the air. Now when this is done, the water vapors get, the water present in the moisture present in the air get condensed, and that condensed moist air will get deposited in the separator where it can be drained out. Okay, so next is the moisture separation. So the condensed water is separated using a moisture separator. Now the moisture separator, it may be of many principles can be there. It can be centrifugal type, it can be mechanical trap also. So an automatic drain valve is used to drain the removes the collected water. Then we have the reheating. Now when the air comes out of the stage 2, it is very cool. The air is very cool, and this cool air is again used to cool down the moist air in the stage 1. So reheating. The cold air, the cold dry compressed air passes again through air to air heat exchanger where it is reheated by the incoming hot air. This prevents the pipeline condensation and improves the efficiency. So what happens? So when the air comes out of the refrigeration unit, it is very cool, but it is compressed also. So due to this, so we cannot use this much cool air for our system. So we have to little bit heat up. So what we do, we pass it to the air heat exchanger, that is the stage 1, where it exchanges the heat of the incoming moist air. So it serves two purposes. The stage 1 serves two purposes. It cools down the air incoming to the air dryer, and it heats up the air that is moving out of the heat exchanger. So that is the functioning of this stage 1. So the dry outlet air, finally clean and dry compressed air is delivered for the use for the pneumatic tools, machines or the processes. So then again the air from this dry outlet can be used for the various other purposes, and it moves to the other components of our fluid power system. Okay, so this is the functioning of the low temperature drying, that is refrigerator type of drying. So next is the adsorption drying. Adsorption. Now first of all, let's understand that what is the meaning of adsorption. So adsorption is the phenomenon where water is deposited on the surface of the solids. There are some chemicals, like we have the alumina, activated alumina is there, silical gel is there, molecular sieves are there. Now when the moist air passes over these chemicals, then the moisture gets deposited on these surfaces, and this principle is used for drying the air. So what happens now? So this is the construction of this schematic of the adsorption type of drying system. So what happens? So moist compressed air entry. So wet compressed air from the compressor enters the dryer unit. So first of all, the moist air from here it enters. So this valve is a rotary valve. It is a type that which it will have a timing to a set timing is there to allow the air to pass into the different directions. So this is the rotary type of valve, always controlled with the help of a timing. Then the moist air enters the first adsorption system. So in this adsorption system, we have a activated alumina, silica gel or molecular sheaves can be there. So the air passes through a tower filled with dehiscent material. So it passes through the power. Dehiscent materials means that this material can be used for adsorption of the water molecules. So the dehiscent adsorbs the water vapor molecules, delivering the air at the outlet. Achievable dew point is minus 20 degree to minus 70 degree centigrade temperature. So here the temperature of the air that can be achieved is minus 20 to minus 70 degree centigrade temperature. Now this system, as you see in the figure, it is also known as the twin tower operation. So there are two absorbents will be there at B and C, and these will be acting in their turn by turn. So the dryer usually has two towers working alternatively. While one tower is drawing the air, the other undergo regeneration. So the meaning of regeneration is that after the removal of the water molecules from the compound, then that adsorption, that tower will be again getting ready to the next stage, that is getting ready for adsorb the next coming moisture. So that is the twin tower of the operation. So once the air, let this is acting as a dryer, then the dry air moves in this dry air moves out, and it can be used for the another purposes. Now we have a shuttle valve, and the function of the shuttle valve is to deflect the supply of the air, and then this shuttle valve, what it does, it moves the air into the next one, and in this turn it will be used for adsorption, and this will be used for regeneration, and the moist air moves in this purge exhaust. So this is the functioning of the adsorption type of the air dryer. So the next one is the absorption type of the drawing. So when we talk about the absorption, now adsorption is the deposition of the water molecules onto the surface of some chemical. Absorption is the absorbing of the molecules by some chemical, and then a chemical reaction will take place and a new compound will be made. So it is purely a chemical process. Moisture form a compound with drying agent causing its breakdown into the fluid. So we have a drying chemical like this here. So the moisture that is present in the air, it will form a compound with this chemical, that is drying chemical, and it will separate out the fluid from it. So fluid is discharged from the concentrate drain. At the bottom we have a concentrate drain is there. You see, this is the drain which is able to remove the moisture from here. So what happens, the moist air enters from this side, and it will react with this dryer chemical present over there. It will form a compound. So this compound will be in the form of the fluid, and it will settle down at the bottom, and it can be drained from this opening, this drain, and the dry air will move up, and it will move here to the next fluid power system components. Now the features of this type of absorption type of dryer system is that it is very simple to install. So no mechanical parts are there, so low wear and tear, because there is no moving parts, no external energy is required in this type of system. So this is the mostly used type of the air dryers in the pneumatic system, that is the absorption type. Now the next component is the air service unit. So this is one of the very important part of the pneumatic systems that has to be discussed. And this air system unit is also known as the FRL unit. So FRL unit, like F stands for filtration, R for regulation, and L for the lubrications. So there are three prime functions that are taking place in a single unit, and so this is also known as the air service. We are servicing the air to be used for the useful purpose. So the main elements of the FRL unit are air filter, pressure regulator, and the lubricator. So these are the three main parts of this air service unit. Now you see, this is the figure of a commercially available FRL unit or air service unit. So you see this first part. So this is the filter. So this is the drain, which can also be used to separate out the moisture if some moisture is condensed at the bottom. At the center you have the regulator. So we have a dial gauge here. We can open up this, we can rotate this knob to adjust the pressure of the air passing out of this system. And the third one is the lubricator. Now the function of the lubricator is to lubricate the air, compressed air, to be used into the system. So we will discuss all these components one by one in this presentation. Now let's first discuss about the air filter. So the air filter and water trap is used to prevent any solid contaminants from entering the system. So we know that the air that is present in the environment, it always contains some dust particles, suspended particles are always there. And if this air is directly used into our fluid power systems, then the components of the fluid power system, those will be very prone to get breakdown. So to prevent any solid particles, solid contaminants entering into the system, we have to separate out those particles, and that can be done with the help of the filter. Then condense and remove the water vapor that is present in the compressed air. So that is done, primarily it is done in the your air dryers, but if some of the left contaminants are also there, then they can be separated into the filter stage also. Okay, so you see that this is the construction of the air filter. So what happens? So we see that from here, the red arrow, it represents the air entering the system. So when air is entering the system, you see this is the cartridge. This is known as the cartridge, as you seen in the green color, and this is the baffle. This is baffle, and this is the deflection cone. So what happens when the air comes in here in this region, the function of the deflector cone is to supply the spread of the air onto the cartridge, filter cartridge, equally. Okay, so we have a baffle. Baffle is to deflect the air passage. Now when the air from this cartridge, it moves inside, so the contaminants in the air, solid contaminants or the impurities that are there in the air, get separated out in this cartridge. So this cartridge is a removable type of the cartridge, and it can be changed from time to time after the after the passage of some time. Now the clean air then moves from here where we have written air out, it is shown with the help of the blue arrow. So if some moisture content is also there, then it gets separated out, then get settled out at the bottom, and we have a plug over here, and it can be opened and it can be used to drain out the condensed moisture from the system. So this is the functioning of the air filter. Now next we are going to discuss about the pressure regulator. So we know that FRL unit, so as the name implies, for filter, a regulator and the lubricator. Regulator means the regulation of the pressure. The function of the regulator is to regulate the supply pressure. So we are getting the air at a high pressure in our the system for which we have employed the pneumatic system. There we require a low pressure air. So that pressure is adjusted by using this pressure regulator valve. So it works on the principle of the pressure difference. So we have two types of the pressures that are being exerting on the system. First is two opposing forces are there. One is the spring force that is acting downwards. So you see this is the cut section of the spring. This the tension of this spring can be adjusted by using this knob. So we can rotate it and adjust the tension of the spring. When we tighten it, the tension increases. When we untighten it, the tension decreases. Now the second force is the fluid force on the diaphragm that is acting downwards. So the spring force will always be acting downwards in the downward direction. At the supply pressure, at the supply pressure that is coming from here, it will be acting upwards. So when let me have set a limit over here with rotating this screw. When the fluid pressure becomes equal to this spring force is acting downwards, the fluid pressure is acting upwards. When these two forces becomes equal, when the supply pressure raises little bit above the spring force, the diaphragm will lift up. And it will allow the passage of the air to the other side. So this is the working of this pressure regulator. So spring force can be adjusted with the help of the adjusting screws. Air from the high pressure chamber is allowed to enter low pressure chamber against the spring force by moving poppet assembly to provide the constant outlet pressure. Okay, so this is this poppet assembly is moved with the help of the moving of the diaphragm. So as the diaphragm lifts up, so it will move the poppet up and this passage will get open and the pressure goes out here at the pressure that is set with the help of the knob that we can see at the dial gauge that which pressure has been set up. So this is the function of the pressure regulator valve. The next part of the FRL unit is the air lubricator. So the function of the air lubricator is to lubricate the compressed air. That is the prime function of the lubricator. So why do we need to lubricate the air that is used in the fluid power system? Because now, as it is in our moving parts, we will be discussing about the valves, next actuators. All valves and actuators, they have the moving sliding parts are there, like pistons under type of arrangements will be there. So if that sliding is not lubricated, then it will lead to the generation of the heat, and that heat will lead to the distortion of the dimensions of the cylinder and the piston. So to dissipate that heat, we need to lubricate the system, and that lubrication is achieved by lubricating the compressed air supply, and that is done in the FRL unit. That is the third portion, that is the lubricator. So what happens? The compressed air is mixed with the mist of an oil in order to provide lubrication to sliding components. So it works on the principle of the Venturi, that is a fluid mechanics principle you have already studied in your previous semesters. So what happens? You see this is the principle explained here. So in one chamber at the down, we have the oil that is at the ambient pressure. Okay. So when the compressed air is coming in this direction, so that will be imparting some pressure on the oil. So the compressed air pressure will be imparted on the oil also. So what happens when there is a throttle here? So throttle is what? Again, there is a decrease in the Venturi formation is there. There is a decrease in the area of the passing, and this throttled area, what there is change in the energy systems. And what happens? There is the low pressure generation at this point. So low pressure is generated here, and due to the low pressure generation, and you see this tube that is put into the oil. This is the oil reservoir, and due to the low pressure, the oil from here it will go into this area. Again, their throttle out is there, and due to this throttling, the liquid oil will get formed into the mist of the oil. It will mix into the air, that is the compressed air. So the mist of the oil, lubricating oil, get mixed with the pressurized air, and it will further used for air and oil system is used further for doing the useful works. Okay, now we move ahead. So air lubricator. So when oil droplets fall on the throttled nozzle, so this is the throttled nozzle. So when the air droplets falls from here into the compressed air, high velocity air follows, break the oil droplets into the tiny particles or the mist. So the high velocity air in this throttled area, so what happens, the high velocity air, there will be the formation of the mist of the oil particles that get mixed with the compressed air, so it mixes with the airflow. So then again, this is the schematic figure of the lubricator that is being used commercially. So we have the inlet of the air is there, so this portion, it will contain the lubricating oil, and this is the capillary, and the function of the capillary is to rise the level of the lubricator into the airflow. So what happens when this inlet air passes from here, then due to this throttling action, the lubricating oil is sucked from here and it moves into the stream of the airflow from here. From here it gets outlet to the system. So this is the venturi, as we seen in the previous figure. So this is the venturi. The principle is of the venturi. So from here the flow rate can be adjusted. So we have the sight glass. We can see the sight glass here, that proper functioning of this system can be checked from here. Okay, so this is the capillary tube. So the function of the capillary tube is to suck the lubricating oil from this chamber to put it into the airflow. So that is the function of the air lubrication system. So this is all about today. So we have discussed about the various components of the fluid power system, like air receiver, then air dryer, and the third is the air service unit, that is the FRL unit. So for the next components, we will be discussing into the next module. Thank you.